Hi, welcome back. So in this video, we're going to continue our discussion of transformations of sine and cosine. This time we're going to start with graphs and work our way back to the formula. So really briefly, here are a few reminders. So this is our summary, the way at least I like to write it, of all of the transformations that can be applied to sine and cosine. So the amplitude is affected by A, the period is affected by B, the C causes a phase shift right or left, and the D shifts the midline. Then I think it's really helpful to start getting it in your brain what sine and cosine look like as graphs. So I try to just draw myself some little sketches a lot just to make sure I can remember it. So sine starts at 0, 0 and goes positive to the right and negative to the left, so it kind of snakes out in that way. Then cosine starts at 0, 1 and then it does the same thing to the both left and right. It has some symmetry across the vertical axis. Okay, so for this type of example we're going to work through, our goal is going to be to find a formula for either the sine or cosine graph. So part of what we're going to need to do is to determine if we want to use sine or cosine for our function. So here I'll give you a graph, and let's start with finding the period, amplitude, and midline. Identifying these things will help us incorporate them into the formula we want to write. So to identify the period, I just want to pick places where I can see the function start to repeat itself. So if I look at 0, -1, and 2, -1, I'm seeing that this is one full cycle. So between these, we do a cycle of up and then down and back, and then this repeats itself. So the distance between these 2 points is 2, and that tells me that the period is 2. You could pick any pair of points where you can sort of identify that the function does a whole cycle in between them. Then for the amplitude, this is the distance from the midline to the top of the function. Basically, I like to look at the whole distance from the top to the bottom and just divide it in half, and so I'm seeing that our amplitude is 1. Then this reinforces the midline, and the midline is at y equals -1. So this is just the line that runs through the middle of the function horizontally. So there we go. Period is 2, amplitude is 1, and midline is y equals -1. Now, part of what I'm going to need to do is to decide if I want to use sine or cosine. So we can often use both, we can use one or the other, but it's typical that one of them is a little easier to use, so let's pick which one seems easier here. If I look at the sine graph, I'm noticing that it normally has a point at 0, 0, and I see here that if I just move this point down 1, the 0, -1, we have a same shape happening. So this indicates to me that it's going to be fairly easy to use a sine function since it's just shifting down by 1. But we could also use a cosine function if we wanted. So you can see that cosine typically starts at 0, 1, and here we have that sort of similar peak point at like 1/2, 0. And so we could like do a phase shift of some sort to get this to work, and I'll talk through that at the end. But for right now, we're going to focus on using a sine function to represent this graph, since it has that similar starting at 0 and then snaking out behavior. So if we're using sine, our possible transformations, I'm just going to write them here, are A, B, C, and D. So I know that the period is affected by a B transformation, where the period is 2 pi over B. The amplitude is affected by the A transformation, and the midline is affected by a D transformation. Then I notice here I don't really have any phase shifts if I'm using sine, so we don't need to worry about C transformations. So I can write in the transformations I do have. I have one for A. I'm going to have something for B. It's related to 2 pi over B. We'll get there in a moment. And then my D transformation is a -1. So I know I have something like 1 times sine of something times theta minus 1. And let's figure out what that something is related to the period. So I know my period is 2, but we need to figure out the B value that's going to go in our formula. We have the other transformations accounted for, we just need to figure out this B value. So I know that the period is equal to 2 pi over B. So I can actually solve this for B to get a formula that we can use over and over again to find the B value. So if I multiply B to the left-hand side, I have that the period times B is equal to 2 pi. Then I can divide both sides by the period, and I get that B is equal to 2 pi divided by the period. and this is the formula we're going to use to find the b value, both in this example and basically all the time when we're trying to take a graph with a different period and write it as either sine or cosine. So okay, we're going to find my b value. I know I have 2 pi and I divide it by the period. The period is 2, and so I'm getting that b is equal to pi. And now I write this in my formula. So I'm not going to write the 1 on the outside. That doesn't actually affect anything. 1 times sine is just sine. And so I have sine of pi theta minus 1 is my final answer for the formula for this graph. Before we look at this with Desmos and make sure we did it correctly, I just want to offer one question. So we decided to write this as sine, but can we write this as cosine? So the answer is yes, and this one I don't think is too hard, so I want to show you how that would work. So if I was to draw a cosine graph without the phase shift, I would have this point at 0, 0, it's shifted down to match, and then the cosine graph would look something like this. So if I was to use cosine, it's actually being shifted to the right a little bit, so I need to get it to line up with these points, that 1/2 0 point. So what I'm seeing is that we're going to need that phase shift, that c transformation, if we want to use cosine. So we still keep pi as the b and -1 as the d, but then we just need to incorporate that plus or minus c. Specifically, since we're shifting to the right, that's going to be a -1/2 inside those parentheses with my theta. So we can write this as cosine. It's cosine of pi times theta minus 1/2, all minus 1. So we're starting with cosine, we're changing the period, we're shifting it to the right by 1/2, and then we're moving it down 1. I think this is a little more difficult to see, and it can often be hard to know exactly what the phase shift is, so I'd say use whichever one is easier, but just know you have a choice. Let's look at these on Desmos and feel confident that we did it correctly. So first I can graph y equals sine of pi theta minus 1, and I'm seeing here that this graph looks like what I started with. It has a period of 2, we're shifted down to -1, and the amplitude is 1. Then when I type in my cosine option, I'm doing cosine of pi times theta minus 1/2, all minus 1, and we're seeing that it lines up perfectly. So there you go, we can also write it as cosine. Okay, let's try another example. I'm going to give us a new graph here, and our task is to find a formula for whatever the graph is. So we'll have to determine if we want to use sine or cosine, and we'll also need to put the transformations in. So I like to identify the period, amplitude, and midline first, and then go from there. So to find the period, I'm going to choose points where I can see the function repeating itself. So I do a whole full cycle down and then back up from 0 to 3 pi. That's 0, 5, and 3 pi 5 on my graph. So since this distance is 3 pi, that means my period is 3 pi. Then the amplitude is the distance from the midline up to the top or the bottom of the function. I see that the midline is at y equals 0, and we're going up 5 to get to the top. So my amplitude is 5, and as I already mentioned, our midline is y equals 0. So as part of this, we should also decide if we want to use a cosine or a sine graph. I'm noticing that we have this point 0, 5, so we don't have a 0, 0 like we would in sine, we have a 0, 5, and this looks similar to cosine to me, where cosine typically has 0, 1 as our point. So I'm going to use cosine as my formula for this. Okay, so we need to take our period, amplitude, and midline and put them into our formula. So the amplitude is the A transformation, it's on the outside, so I have 5 times cosine. Then the period is going to be multiplied by the theta. We're going to need to deal with that in a moment, so I'm just going to leave it as a box here. And then the midline doesn't change, so it's just a plus 0 at the end. And if I compare this to all my possible transformations, I see that I have that A and B transformation, and really there's no C or D transformation happening. The D is like plus 0, but I'm just going to take that out. It doesn't affect anything. Our midline hasn't changed, so I like to think of it as not really having that transformation present. Okay, now we need to find our B value. So I know that 2 pi divided by the period is equal to B. So my period is 3 pi, so I'll do 2 pi divided by 3 pi equals B. And that's just B equals 2/3 once I've canceled those pi's. So putting that into my formula, I have 5 cosine of 2/3 theta, and that is my formula for this graph. Before we look at it in Desmos, let's just talk about if we can write this as a sine function instead. So can we write this as sine? Well, the sine graph would have a point at 0, 0. So I'd say that similar point is this point to the left, so it's sort of been shifted from where it would have been if it was sine. So sine would have 0, 0, and then the graph would look something like this. So we would need to shift sine to the left by some amount. But just looking at it, I'm not totally sure what that amount is. Like, without being given a better graph, like with just this one I'm given, I don't know what the phase shift is. I can't really tell. So I would choose not to use sine for this, even though it's possible, just because I would need to guess or something and I'm not totally sure what it is. So if we look in Desmos, we can check this out really quick. So I can graph what I decided the function was. I said it was 5 cosine of 2/3 theta, and when I do this, it looks good to me. I have that period of 3 pi and the amplitude of 5. Then I'm just going to play around a little bit with what the phase shift might be, just to see what I can find. And as I try different things, I'm getting that the phase shift is plus 3 pi over 4. So we're shifting to the left by 3 pi over 4. I think just looking at the graph I was given, without being able to zoom in or see better units, I couldn't really tell what the phase shift was. And so in this case, it's a lot safer just to use the cosine graph. But if you ever can tell more specifically what the phase shift is to use the other type, so to use sine in this case, you can feel free to do that. It's definitely possible. It just sometimes might be more difficult to use the other trig function. So okay, let's do a little summary as we end this video. So one of the main takeaways is that there are often multiple correct answers for writing formulas from graphs. You'll just notice in general, you can often write it as either sine or cosine. One might be easier than the other, but there's always going to be options for you. You can choose what you like. There isn't one better or worse way to do it. You get to have some freedom here to do whichever cosine or sine feels better. Then the last thing is a reminder that if you know the period and you need to figure out the b value for the transformation, you should use that b is equal to 2 pi over the period. Okay, that's it for this video. Good luck practicing these, and remember, just be kind to yourself as you're working through these things for the first time. Thanks so much for watching, and I will talk to you in the next one.